parent functions. Here we go. There are 6 parent functions that we're going to discuss. Okay? Parent functions mean that when I graph, I only have the x value here. The invisible one is with it. There is nothing added to it or multiplied to it. It is the basic graphing function. Okay, so our first parent function is y equals x. This, ladies and gentlemen, is a linear function. Okay, it is a linear function, which means it should create a line. Now, the way we do that is make a table of values, which we already have done. Okay, we already know how to do that. The idea is to determine your domain, which we have done that before too. We're going to use what we refer to as a universal domain. Okay, and we're going to put 0 about in the middle. Okay, because we want some negative numbers above, we want some positive numbers below. Okay, so that we can get an idea of where that graph is going on either end. Okay, so -1, -2, -3, and then 1, 2, 3. I don't need that bottom row, so I'm not going to use it right now. Okay, so how do we get the y? Well, this is the x that we determine what it is. And then to find the y equals x. So what in this case, whatever x is, that's what y is. So when x is -3, y is -3. When x is -2, y is -2. When x is -1, y is -1. And we continue that same pattern. Then we graph it. Okay? So I'm going to start at -3, 1, 2, 3, and it is -1, 2, 3. Okay, when x is -2, 1, 2, y is -2. When x is -1, y is -1, 0, 0. When x is +1, y is +1, and we continue that pattern, and you will need a straight edge. You must make straight lines when you have lines. They must be straight, so you must use a straight edge. Okay? And that is a linear function. Linear meaning forming a line. Okay? So that takes care of our first parent function, which is a linear function. Okay? Let's talk about our second type of function, where now the x is squared. Okay? So let's check that out. We're going to use that same domain. About in the middle, we're going to put that 0, -1, -2, -3, +1, 2, 3. And again, I don't quite need that last row, so I'm not going to use that. Okay. Now this time, when I substitute in for the x, it's going to be squared, so I'm really going to need to use those parentheses. Okay. So here we go. Y equals -3 squared. Y equals -2 squared. Y, and then this same pattern continues all the way down. Okay. Okay, so that's what we're doing there. We're writing that out so we can get those answers. Okay. So -3 squared is +9. -2 squared is 4. -1 squared is 1. Because -3 times -3 make a +9. Okay, 0 squared is 0. 1, 2 times 2 is 4. 3 times 3 is 9. And then we are going to graph that. Okay, here we go. So, -3, so x is -3. 1, 2, 3. And then y is positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Negative 2, 1, 2, 3, 4. Negative 1, positive 1, 0, 0. Positive 1, positive 1, 2, positive 4. What are you noticing? And then 1, 2, 3. They're a mirror image of each other, right? This is very symmetrical. Now, if you use a straight edge, you will notice that this does not make a V. It does not. This actually makes a U shape. So make sure that you round that out. Okay? And then come up through your arrows on both ends always. Straighten that out a little bit. Okay. So, that is called a parabola, just so you know, but it makes a U shape. The x squared makes the U shape. Okay. So, let's look at our next parent function. Y equals the absolute value of x. Okay. So, this is referred to as an absolute value. Sorry. L U E function. We're going to abbreviate that for fun. Absolute value fun. Okay. Oh wait, I forgot to name this one. This one is quadratic fun. Okay. Apologize for that. You know how excited I get when I know the answer. A quadratic function, which is a U shape. Okay. Absolute value function. Let's see what it does when we graph it. So, what is my domain? 0 in the middle, negative 1, negative 2, negative 3, positive 1, 2, 3. Okay? Remember that the absolute value is distance from 0, so it's always positive. Okay? On your calculator, you will need your template for this. Okay, your calculator template that I gave you, and we filled that out. Should have done that like day 2, but we're going to go to math, arrow over to numbers, and we're going to choose number 1 that is A, B, S, just like that. Okay, so that's where that is in case you need that. But the absolute value of negative 3 is positive 3. Absolute value of negative 2 is positive 2. The absolute value of negative 1 is positive 1, 0. And the absolute value of 1 is 1, 2, and then absolute value of 3 is 3. And then when we graph this, we're going to start negative 3 on the x, positive 3 on the y, negative 2x, positive 2y, negative 1, positive 1, 0, 0. Positive 1, positive 1. And notice how that makes a mirror image also. However, because the x is not squared, it really does create straight lines. So in this case, when you have an absolute value function, you've got a V shape. So absolute value makes a V shaped graph. Value V. That's one way to try to remember that. Okay. So that's what that looks like. So the idea here is to learn these parent functions, to know what they look like, so that we can know what these different functions are called, okay, based on their shape. I would expect you to know what these are, what these graphs are, based on their shape, okay? Let's go to our next one, which is y equals square root of x. Now the square root button. So guess what this one is called? Excitingly enough, that's right, square root fun. Because of the square root symbol, which is second. So to get to that, it is second and then x squared. The square root is right above that x squared button on your calculator. Okay? Now, again, we're using that same idea for our universal domain. 0, -2, -1. Oh my goodness, now I can't even count. Sorry. Let's try that again. -1. Okay, not two negatives. Woo! Okay. -1, -2, -3. 1, 2, 3. And this time we are going to use that last row. Okay, we're going to use this last column. Here we go. So when you type this into your calculator, which I do want to show you, because it's just good times right here. Okay. When you go to your calculator, okay, and you type this in, and I did put on the stream a way for you to download the graphing calculator, okay, the TI-84, which is a good idea for you to do, and if you can do that, that'd be great. Here we go. So, when I type in square root of -3, second x squared gives me my square root, and then I type in -3, enter, what do I get? Error. But what kind of error is it? Because that matters. Some errors we can fix. This one is non-real answer. You can't fix that. It's a non-real answer, which means for us in Algebra 1, it does not exist. Non-real answers do not exist for us. So you're going to put error right here. Error. Every negative number will give you an error. Okay? But then the square root of 0 is 0. The square root of 1 is 1.41. The square root of 2, the square root of 2, I apologize. I apologize. I apologize. I've got this in the wrong place. 1, 2, 4, 9. Because the square roots of perfect squares are going to give us a much better graphing situation. So, the square root, second x squared, of 1 is 1. So we're going to write that down. Sorry, I got a little excited. The square root of 2 is 1.41. The square root of 4 is 2. The square root of 9 is 3. Okay, so let's look at that. That's going to be a much better graph, easier to graph here. We cannot graph any of those. Okay, we cannot graph those. So here we go. We're going to start at 0, 0. So when x is 0, y is 0. And then when x is 1, y is 1. And then when x is 2, y is 1, almost half, not quite. Just get it close. But then when it is 4, 1, 2, 3, 4, 1, 2. When it's 9, 1, 2, 3. Look how slowly that rises. Okay? Here is 4, here is 9, and it didn't hardly go up at all. So we start here, and we just go like that. Okay? Only one arrow this time. Okay? And a square root is going to always start at 0 for us. Okay? So here's our square root. The parent function is going to start at 0. So there that is. square root function based on what it looks like. It almost kind of looks like the square root, right? Symbol. Okay, our next one is our next parent function. This is what we call, what is this called right here? An exponent. So this is an exponential function. So it's exponential fun. Okay. So let's see what this does. We're going to start 0 about in the middle there. -1, -2, -3, and then 1, 2, 3. Now, the thing about exponential functions is when you graph it, it never intersects this x-axis, ever. It never gets there. It gets really, really close, but it never gets there. Okay, so let's look and see what that means. So, when you're looking for the exponential button on your calculator, okay, it is, you're going to push, let me show you where that is. My calculator pulled back up. It's acting crazy. Okay. So the EX is also E to the X, I apologize. E to the X is also a blue function right here above the LN. So you're going to push second LN to get there. Second LN. And it's going to get you to E to the X. Okay? So let's see what that does. So I'm looking at second LN. Second LN. So look at that. It gives me the E and then it says, hey, what do you want the exponent to be? I want it to be -3. There we go. And we're going to go 2 decimal points just so we can see where we are. And it'll be 0 point, round it to the 5. Okay? So that's what we will do. Second LN, and we're going to raise it to the -2. Second LN, raise it to the -1, and we will continue in that pattern. Okay, so let's write those answers down. So we have 0.05, and then we had so I used to put the 0 in front. I'm just going to do it 0.14, and then I've got 0.37, and then 0 is actually 1. And then 2.72, 7.39, 20.09. Wow, look how fast that grew. Exponentials grow really quickly. Okay, they grow very quickly. So when I'm at -3 with the x, 1, 2, 3, then I'm at positive half. No, not half, I apologize. 1, 2, oh, right there, almost on the line. And then -2 is just slightly above that. And we have our pencils and pens will not even get that close to the line without touching it. So we just got to get really close, just don't touch it. And then at -1, we're still not at half. So it's just barely coming up, okay? And then at 0, we're at 1. Then at +1, we're at over 2.5. And then at 2, 1, 2, 3, 4, 5, 6, 7, not quite half. And then 3 won't even, here's 3, it's, I don't know, up here somewhere. So this is what I'm telling you. So when we graph exponentials, you're going to start here and you're going to get really close to that x-axis. Just don't touch it. And then it's going to come up like this, and then you're just going to connect to your points. Okay? Arrows on both ends because it extends in both directions. And this is what an exponential parent function looks like. It's like an L. Okay? So that's what that's, and it grows very, very quickly. Very quickly. Look how quickly that goes up. As opposed to the square root, Which, look at that. It took a long, I mean, this is from 4 to 9. This is from 1 to 2. Look at the difference. Okay? All right, now, our final parent function is y x cubed. This is what we call cubic function. It's a cubic function. Wrong color. So this is cubic fun. Okay? This is cubic fun. So again, we use that same domain. -1, -2, -3. 1, 2, 3. The only one that doesn't follow this pattern is our square root, right? Because I kind of want to go by perfect squares to be able to plot those just a little bit better. Okay? Now, cubic function, in order to get to that, you're going to have to push the caret. I'm sorry, it's a K. It's called the caret. And then the 3. Okay? So let me show you what I'm talking about here on the calculator. Okay? So if I'm looking here, y equals x cubed. So as a reminder, that you need to put these in parentheses. So x, which is -3, and I want to remind you on this calculator, the negative button is below the 3. This is negative. This is an operation of minus, but this is your negative button. Make sure you use negative. You're going to close that. Here's the caret. The caret is just right above that division. Okay, the button right above the division symbol. Raise it to the 3rd power. I want you to notice how this is blinking. It's an arrow blinking. And what it's asking you is, are you done with the exponent? Are you done with the exponent? If you are, you're going to need the arrow to the right to come back down. Okay? Now, oh goodness, I got 2 parentheses in there. Let's try that again. -3, close, raise to, no. I apologize. Let me try this again. -3, raised to the 3rd power. There we go. Okay, -27. -2 raised to the 2nd power. No. Still cubed, it's all cubed. Okay. -1 raised to the 3rd power. Okay, and that just continues in that same pattern. Okay, so let's get our answers for that written in there. So we have -27, -8, -1, 0, 1, 8, and +27. Okay, so this is what a cubic function looks like. First of all, there is not a 27 on here for us to graph, so we're not graphing that. But -2 and -8. -1, -1. 0, 0, +1, +1, +2, +8. And of course, +327 won't fit on the coordinate plane, so we don't graph that. But look at this. This is what a cubic function does. It kind of twists in the middle. Arrows on both ends. So it has a little twist in the middle. Okay? So the goal of this lesson is for you to be able to look at these parent functions and recognize them and know what their names are based on their shapes. Okay? So these are parent functions. And their names. Okay? Your homework will be posted on the classwork.